Hi, this is Tony Northrup for TrainSignal, and in this lesson we're going to learn how to configure and maintain network security in Windows 8. We're going to cover both local security and security using group policy that can apply to hundreds or thousands of computers in a domain. This lesson maps directly to Objective 3.3 for the Microsoft 70-687 certification exam. Here are all the official sub-objectives. They want you to know how to configure Windows Firewall. And the next sub-objective says configure Windows Firewall with advanced security. These are just two user interfaces to accomplish the same thing. The third is to configure IPsec rules. IPsec is a standard protocol that provides both authentication and encryption for communications. Basically, when you connect to a server, the server knows that you are a trusted computer and you know that the server isn't an impersonator. And then all the communications between the client and the server will be encrypted so somebody listening on the line can't intercept all the communications. The next objective, configure authenticated exceptions, just allows you to make exceptions for connections that won't be protected by IPsec when you have to communicate with old protocols that don't support it. The next sub-objective, configure network discovery, simply turns on or off the network discovery feature, which allows computers to find each other. It's generally not used in enterprises. It's more of a home network thing, so it's turned off by default, but we'll check out how to control that if you want a different setting. Finally, we'll talk about managing wireless security, and this is a little different than you might be used to when managing wireless networks on an individual computer. We'll talk about how to use group policy to configure wireless networks for your enterprise. Let's get started by learning to configure Windows Firewall. Here's my Windows 8 Enterprise computer, and first I'll search the start screen for Firewall. I have to search settings for it, and I'll pull up the standard Windows Firewall app. And you can see that this is the user interface. Windows Firewall is configured separately for domain networks, private networks, and then public networks. And you can see it's turned on by default for all three of them. What Windows Firewall does is it listens to every packet, every network communication that's sent to a computer, and it evaluates it, and it checks it out to see what app it's for, who it's coming from, and it determines whether it should be allowed or not. Firewalls are tremendously useful. They help block a portion of the network attacks that might otherwise infect your computer with malware or something else. I'll tell you about the world before firewalls. Earlier versions of Windows, say Windows NT, didn't have a firewall built in. And at the dawn of the internet, well, the dawn of the modern internet, which is the late 90s, the crafty hackers started writing scripts that would just scan the internet for computers that were connected and listening for incoming connections. And whenever they found one of those computers, they'd send them some special communications that would hack the computer and take control over it. This was rampant. Like, millions of computers were infected with various types of malware, and they did nothing other than connect to the internet. And it was so bad, I was responsible for managing a few thousand computers that were connected to the internet. We were doing web hosting. You would plug a server into the internet, and within 2 to 3 minutes, it would get infected. We even used firewalls, but we found out that the firewall wasn't in effect just during the setup process, which only took a couple of minutes. That was long enough for attackers to get to it because bots were scanning every IP address constantly. So that's the importance of firewalls. They protect you from that sort of threat. Now, they're not foolproof. You still have to make firewall exceptions to allow legitimate communications. And so nowadays, those types of attacks still happen. They just piggyback on legitimate communications like web browsing. Now, this is the consumer interface for configuring Windows Firewall, so it's meant to be really straightforward. You can see the top link here, allow an app or feature through Windows Firewall. When you click that, it brings up the non-administrator user interface, which simply lists every app that's allowed to communicate and which types of networks that is allowed to communicate to. So you can see that Windows 8 has SkyDrive installed by default, and as a result, Windows 8 has a firewall exception for domain, private, and public networks, and SkyDrive is allowed on all of these. If you don't use SkyDrive in your organization, you probably don't want a firewall exception for it. So this requires administrative access, as you can tell from that little shield there. So I clicked that, and because I'm logged on with an administrative account, it automatically elevated my privileges. Now I can just clear that checkbox to disable SkyDrive for all profiles, or I could turn it off for just private and public and still allow it when the computer is connected to a domain. So that's how easy it is to turn off an existing firewall exception. Now say things like an exception for the weather app aren't as bad as they seem. This particular exception is going to be very well crafted so that it's not allowing, say, random attacks through. In other words, by allowing people to check the weather, you're not making a huge security compromise. This particular exception simply allows the weather app to communicate with the weather servers that it needs to connect to. Again, the fewer firewall exceptions you can have, the better, but all these firewall exceptions that are enabled by default are there for a reason, and generally it's to make apps work properly. So by turning them off, you could be breaking existing apps. If you want to allow an app that's not listed, click Allow Another App, and just walk through the wizard that appears. It's pretty easy. In the old days, you had to worry about port numbers and IP addresses every time you configured a firewall rule. Nowadays, it's much easier. You pretty much just pick the app that you want to allow through, and Windows takes a look at the app, determines what it's going to communicate with, and just allows that app to do anything it needs. The Network Types button down here allows you to pick the types of networks that you want to allow the app to communicate. I'll add that by default, Windows 8 has firewall rules that allow client apps that are initiating a connection, say to a server on the internet, to initiate connections to any server on the internet. So these client app rules, like the Bing rule here, aren't strictly required. You could turn it off and Bing would probably still work. And the reason is there's another firewall rule that allows everything through. The reason that these rules exist, even though they're redundant, are for organizations that want to restrict apps even further by blocking client communications. So that's the standard Windows firewall interface. There's also the advanced interface, which provides a lot of the same functionality, but gives you much more detail. You can see this is the Microsoft Management Console interface, and it divides the firewall into inbound rules and outbound rules. Inbound rules are for connections that are initiated from a server to the Windows 8 PC. These aren't especially common. They don't happen all that often. But if you make a Skype call, Skype needs to connect from their server to your PC. So that would require an inbound rule. An outbound rule is for client connections initiated from your Windows 8 PC. So these are most of the connections that a client computer makes. Anytime a web browser contacts a web server, an outbound rule needs to exist that will allow it. You can see that there are a ton of outbound rules here configured by default. There are separate rules for everything from, this rule is for DHCP, which automatically acquires an IP address. This rule here is just to allow all IPv6 communications to go out. Here's a rule that allows file and printer sharing on private networks. You can see it's disabled on public networks. So let's take a look at how to make a new rule. I'll click new rule here under, we'll make an inbound rule. Now, when you create a new rule, you can see it gives you 4 different choices: program, port, predefined, and custom. When you select program, you select an app or service, an executable file basically, and Windows 8 is just going to let that app do whatever it wants, at least according to the rule that you specify. Now, port number is a field in an IP packet. So think of an IP packet like a letter that you might mail somebody. Port would specify the specific address on the letter. So each packet must be addressed to both a computer and an app on that computer. The IP address specifies which computer the packet is going to, and the port specifies which app on that computer. In other words, you can create a firewall rule for ports to specify just specific ports that you happen to know an app uses. Let's take a look. Let's open a web browser here, and we'll search for standard TCP ports. Thank you, Wikipedia. Now, I happen to know that web browsers always use port 80 by default when they're not encrypted. So you can see there's a port number here, protocol TCP, Hypertext Transfer Protocol, which is what web browsers use. You can see each of these is a different app. SNMP here is on 161 and 162. Most apps have their standard port numbers that they use. Now, nowadays, it seems like most apps piggyback on HTTP at port 80 and HTTPS at port 443. And that makes filtering based on port numbers a little more useless because you can't really use the port number to differentiate anymore. For example, Skype, not browsing the web, right? But it'll still use HTTP and HTTPS specifically to bypass firewalls, because everybody has firewalls on their networks now that block all sorts of communications, except everybody wants people to browse the web. So as a result, all the new apps that have come out for the last decade or so pretty much use HTTP. It makes it easy to get around firewalls, but it also makes port filtering a little more difficult. Nonetheless, you can create firewall rules based on port. And if you need to find out the port number for an app, as I just showed you, you can pretty much just Google it. Now, predefined is a particularly useful rule type. Microsoft has created a bunch of standard rules for you for things that they think you'll want to either block or allow. For example, network discovery isn't a particularly popular service. A lot of people want to turn that off, so you'll see that there's a predefined rule for network discovery. Custom rules simply allow you to configure any set of options, including multiple combinations of programs and ports. So let's create a port rule, and we'll just allow port 80, even though it's already allowed. So they even use it as an example here. We'll list both port 80 and port 443, which you might have called port 80 as HTTP and 443 as HTTPS, the encrypted version of that. So you can see we have the option to allow the connection, which will simply let any traffic for port 80 through. We can allow the connection if it is secure, which applies IPsec rules. We'll be covering IPsec a little bit later in this lesson. Or we can block the connection, which would block all traffic for port 80 and stop people from browsing the web and probably ruin their day. And on this page, we just select which profiles the policy applies to. So if you wanted it to only apply to the domain networks, you could clear these two options. And finally, you have to name it. So we'll just call it port 80 and 443. And that's all it takes to create a firewall rule. This, of course, is done on a local computer. So let's hop over to a Windows Server 2012 computer, and we'll use group policy to do the same thing. This is Windows Server 2012 and the Group Policy Management Editor. The policies that I define here could apply to every computer in an organization or just for, say, the accounting department. Windows firewall rules are configured under computer configuration, Windows settings, security settings, and then Windows firewall with advanced security. This looks familiar, right? It is literally the exact same user interface that we were just working with, except specifically within the group policy editor. So instead of configuring new rules for one computer, it will configure it for every computer. So this is exactly the same wizard, and we won't have to walk through it again. But if you wanted to do it for everybody in the enterprise, this is what you'd do. So now let's go over a real world scenario for Windows Firewall. What we're going to do is pretend that the IT department has decided that they don't want random people connecting to their desktops using remote desktop. They want to block all remote desktop, but the IT department still wants to be able to manage computers remotely using remote desktop. So all their management computers are on a single subnet, the 10.10.10.0 subnet on their network. What they'd like is for computers on that network to be able to establish remote desktop connections, but not computers coming from any other network. So let's look at how to do that using group policy. We'll jump back to Windows Server 2012. This is going to be a rule that applies to the client computers in the organization. And because remote desktop is initiated from the user running remote desktop to the client computer is actually the server, and that requires an inbound rule. So the first thing we'll do is we'll block all remote desktop connections. I'm going to use a predefined rule here because Microsoft has been kind enough to provide one that applies to remote desktop. You can see that it's going to create two different rules, one for UDP and one for TCP. Those are simply different IP protocols. UDP is oriented for high performance communications, and TCP is designed to be more reliable. It automatically retransmit if something is dropped. This prompts us to choose the action, whether we want to allow it or block it. We're going to make a rule that blocks all communications first. So now that we've created an inbound rule to block everything, we're going to create a second rule that will be the exception to that. So let's make this a custom rule. We'll select the services and specifically pick the remote desktop service. Now, you don't necessarily need to specify a program and a port number, but for the sake of an example, let's configure this for port 3389, which is the port that remote desktop uses. Now, remote desktop is a server service and it uses port 3389. So to the Windows 8 computer that this policy is going to be applied to, the local port is port 3389. Now, the way TCP works is the client computer makes up a random port number that's something above 1024. So you can't guess what it's going to be because it's going to be random. So in this case, because it's applying to the server, we don't know what the client's port is going to be. Therefore, we're going to leave remote port set to all ports. And here's where we get to select the scope. So the local IP address is the IP address of the client computer, and we don't know what that's going to be. It could be anything. So we're going to leave this to be any IP address, but we do know what the remote port is going to be. These are going to be the administrative computers on the 10.10.10.0 network. Now, I'm structuring this according to this example here, and I can't go into a great deal of detail about how IP addressing works, but basically this is the subnet that the network administrators told me, and this is the subnet mask. Each one of these octets, as you might tell from the name octet, is 8 bits long. Therefore, there are 32 bits in an IP address. The /24 indicates 3 8-bit octets because 8 times 3 is 24. So by saying /24, I'm saying that this is the network address. If you're more familiar with subnet masks, /24 would be equal to 255.255.255.0. Starts to make sense if you are familiar with Boolean math. If not, just know that your network administrator will tell you the subnet that you need. And if that gets too confusing, you also have the option of specifying it like this. So these two are exactly equivalent and they work the same. Now on the action page, we're going to allow that connection, and we can apply it to the domain profile because we know the users are always going to be connected to the domain. It wouldn't hurt to apply to these other profiles since it's so specific, but there's no need to apply a firewall rule in more places than it needs to be. So we'll name that and we're done. So now let's talk about how to configure IP security, commonly known as IPsec. IPsec authenticates and encrypts your network communications as long as they're within your domain, as long as they're within computers that you manage. Oddly, there's no great way to encrypt and authenticate connections between two random computers on the internet. All we have for that is HTTPS, so it only works with apps that use that particular protocol. However, within an organization, you can authenticate and encrypt any sort of traffic. Now, if you don't have a background in networking, I want you to absorb the importance of IPsec. Everything you do on your computer that results in a network communication, by default, there's no encryption for it. you can be reading your email, and anybody who has access to your network cable or the router or any router between you and the server or any of the network equipment, they can see your email. They can read every word in it. There's no inherent security in IP communications. It's transferred in clear text. It makes wiretaps exceptionally easy. Now, it kind of blows my mind to think that this is the default. The reason for this is that IP was developed in the late 60s and early 70s, and they didn't fully understand the risks of it, and also, frankly, cryptography hadn't come along far enough. We didn't even have the computing power to readily encrypt things. So we're working with this really, really old protocol that's older than even me, and it's not secure at all, and as a result, stuff has been hacked left and right over the decades. IPsec is this fairly recent effort to get this a little more secure. So let's talk about how to configure that in an organization. We'll jump back over to Windows Server 2012. The policies we're configuring here will apply to our Windows 8 computers. And in fact, if you configure it in Windows 8, it looks exactly like this. Now, in the same node, we're under Computer Configuration, Windows Settings, and then we'll find IP Security Policies on the Active Directory. You'll see 3 policies are configured here by default. And notice that none of them are assigned by default. What this means is that IPsec isn't enabled by default in organizations. It requires some configuration. However, it's actually pretty straightforward to set up. Once you have your domain working, the domain controllers themselves do most of it. So we'll talk about first the 2 options we have here for servers. Now, most modern operating systems support IPsec, including non-Windows operating systems. It's not a Windows thing, it's an open standard. So Macs and Linux computers and your iPhone even, they can all support IPsec. However, not everything out there might be configured to support IPsec, and older computers wouldn't be able to support it. So for that reason, this policy exists, Server Request Security. And when you assign this policy, any servers in your organization will ask clients to authenticate themselves so that they can encrypt communications. However, if the client can't support IPsec, the server will continue with the connection unsecured. This provides encryption whenever possible, but it doesn't cause existing apps on clients that don't support IPsec to break. So request security is kind of polite. It allows backwards compatibility, it doesn't break anything, but it assumes some security risks. A secure server, on the other hand, requires security. Every connection coming to a server that has the secure server policy assigned must be authenticated and encrypted, and if a client can't support IPsec, it doesn't connect to the server, which means the apps just break. Before you apply a secure server policy to an organization, you really need to test everything well to make sure that apps don't break. Otherwise, you're going to turn this on and suddenly you're going to be getting a ton of support calls because apps aren't working anymore. So these are 2 policies for the servers. There's also 1 policy for the client, and this is the one that would apply to Windows 8 computers. The client policy that's created by default is respond only. This means that when you assign this policy to client computers, the computer won't ever attempt to turn on IPsec. It'll just establish regular unsecured connections to every server that it talks to. If the server comes back and it says, hey, I need IPsec, the require security policy, or if it comes back and it says, hey, I'd like IPsec, it's okay if you can't, but I'd like it, then the client will respond, yes, I support IPsec, let's get this authenticated and encrypted. So in most organizations that aren't willing to break everything, they turn on the client respond only policy and the server request security policy. Now you can only have one of these policies assigned at a time. In an organization, I'm working with a default domain policy. An organization would have separate group policy objects assigned to the server, so they would create a separate group policy object and turn on request security for the servers in their organization. But we'll assume that this is the client group policy object. So this defines the default behavior, but it doesn't actually configure any IPsec connection security rules. This is configured using the Windows Firewall with Advanced Security Console, and this is exactly the same as the console that you would see within Windows 8 itself. Once you select that node, we'll create a new rule here, and we'll bring up the wizard that allows us to configure IPsec rules. You can see that there are several different types of rules that you can create. This interface is really similar to Windows Firewall, but whereas Windows Firewall simply allows or blocks connections, IPsec is much more powerful. It can actually authenticate connections. So when you have IPsec turned on, every user and every computer has its own security credentials. A client computer can connect and authenticate to a domain controller. The domain controller will be sure that the client computer really is allowed in the organization, and the client computer can be sure that the domain controller really is a domain controller and isn't just impersonating a domain controller to get its username and password. That's because they will all have certificates issued by a public key infrastructure. That all sounds pretty complex, and all of that is server infrastructure stuff, so you won't go into detail in this Windows 8 certification exam, but the fact is most of it is configured automatically once you set up an Active Directory domain, so it's not as hard as you might think. Let's go over these different rule types. Isolation, that's a really strange word to use for this, but isolation policies basically allow you to configure or require IPsec for different communications, and most of the rules that you make are going to be isolation style rules. An authentication exemption, which is specifically named as one of the sub-objectives on the exam, allows computers to not communicate with IPsec when the rule would otherwise be required. So as I was saying earlier, not every computer and not every app supports IPsec. DNS, which is used for name lookups, is one of those things that isn't typically IPsec protected. As a result, you often end up creating an authentication exemption for DNS computers. The server-to-server rule type requires connections to use IPsec between two specific groups of computers or even two individual computers. So if all your domain controllers were configured for IPsec, but the rest of your organization wasn't quite ready, you could create server-to-server rules just to make sure the really critical domain controller communications were authenticated. A tunnel is a fancy way of saying that all communications between two computers are going to be encrypted. IPsec kind of works like a tunnel in that it takes regular IP communications and channels it all through this IPsec tunnel. That's why they call it a tunnel. And as with firewall rules, custom simply allows you to choose from any of the different wizard pages that you would use for these other rule types. So let's create a quick isolation rule. You can see we have options here for requesting authentication, which means that it'll fall back to non-authenticated connections if both the client and server don't support it. Require authentication for inbound connections and request it for outbound connections. This is basically like having the client respond only policy and the server request authentication policies. It means that clients will use IPsec whenever they can. Servers will always require it though, and this is generally a pretty good way to do things in an organization because while you don't always have control over the clients, and clients tend to be much more numerous and might be weird old Linux boxes or mobile phones that don't quite support IPsec correctly, you generally have better control over the servers because they're fewer in number and managed a little more tightly. And if everything in your organization supports IPsec, go for require authentication for both inbound and outbound connections. It's the most secure way, and it means that all your communications that you don't have an exception for will be encrypted. Now, the authentication method allows you to define whether you're authenticating the computer or both the computer and the user. I mentioned that both the computer and the user have their own credentials, so you can authenticate either or both of them. I also want to talk about this term here, Kerberos. Kerberos is some mythological animal, but in this context, it's simply a authentication standard. See, IT nerds like to get a little dramatic, so they mix in things like chimeras and Kerberos, which are like fiery demons and stuff to make it sound exciting, but it's really quite a boring protocol that just allows authentication in an organization, and it's what Active Directory uses. So now we get to choose the networks that the rule applies to, domain, private, or public. You can't really create IPsec rules that apply in public organizations. I mean, you can, but what will happen is nothing's going to work. So generally you create IPsec rules within a domain, and we can name it. So I created that as an example, and I'll go ahead and delete it now because we're going to walk through a scenario. So in this scenario, we work at one of these mythical organizations that's ready to require IPsec throughout the network. So we're going to create a rule that requires IPsec for all communications. Then we're going to scale it back just a little bit because our DNS servers don't support it yet. So we're going to create an authenticated exemption for our DNS servers. Let's get to it. We'll use group policy, so I'm going to go back to our Windows Server 2012 computer. Now the first step is going to be to assign one of these IPsec security policies. And as I described earlier, in the group policy object for the clients, we'd want to enable the respond only. And in the group policy object for the servers, we'd want to assign the secure server policy. So I was saying, in an organization that's requiring IPsec everywhere, why would you assign client respond only and not create a new policy for client require security? The answer is the client's going to need to be able to communicate on the internet, almost certainly. Like, you can't take away people's internet, right? Well, servers on the internet don't support your IPsec, so you can't ever create a rule that just makes the client use only IPsec unless it doesn't do anything on the internet. So we'll jump over to the connection security rules and create a new rule that basically requires IPsec for all communications between computers in our domain. So this will be an isolation rule. And we're going to require authentication for inbound and outbound connections. And we'll accept the default authentication method and apply it only to our domain. After all, when a user takes their mobile computer home, we don't want to force them to use IPsec on their home network. Now let's create a connection security authentication exemption. So I'm creating a new rule of the type authentication exemption. And we're going to specify the computers that are exempt from the authentication. To make this a little bit easier, Microsoft has provided several predefined sets of computers. One of these is DNS servers, so I'll select that. Once again, it applies only to the domain network. So now we have two policies, one that requires IPsec and one that exempts the DNS servers. Scenario completed. Now let's talk about network discovery. Network discovery is this protocol that's terribly useful in home environments. You can connect your Windows 8 PC to the network, and it can find other Windows 8 PCs, it can find your printers. It kind of announces to the network, hey, I have a printer shared here, and I have a bunch of music files shared here and videos, and you might want to play them on your TV or something. It allows users to get stuff up and running and to configure sharing without really knowing how it all works. It makes life much easier for the non-professionals out there. However, in a domain, you probably don't want all your confidential data being broadcast across the network. Like, you don't want to be like, I have a shared folder here called personnel files for everybody at the coffee shop to see. That's not a good idea. So by default, network discovery is only enabled for home networks, for private networks. It's turned off in domain networks, and of course it's turned off in public networks. Let's jump in and see how we can change that configuration default. So I'm going to search these settings for network discovery. And this opens up the home group page in the control panel. It's not actually what we want though. From the home group page, I will click the Change Advanced Sharing Settings link here. And this shows the settings for each of the different network profiles. You can see I'm connected to a domain right now, so it shows the domain profile as the current profile. And you can see the defaults here. Network discovery is turned off, and in fact, file and printer sharing is turned off. If you look at the guest and public profile, which is what would be applied to, say, hotspots, coffee shops, airports, it's also turned off. Good. We don't want that anyway, right? Now, private networks, as I was saying, home networks, it is turned on. If you didn't want that, you would simply select Turn Off Network Discovery. For an individual computer, that's all there is to it. But let's look at an enterprise scenario. Now let's look at a real-world enterprise scenario. You're an IT guy and your manager has just identified a potential security vulnerability in the network discovery protocol. This security vulnerability would allow an attacker running an existing piece of software to compromise any computer that had network discovery enabled. Now that attacker would need to be on the same network because otherwise your enterprise firewalls would stop the communications. But it's still a real threat that somebody else on the network could use it to exploit another computer. Your boss wants you to configure Windows 8 so that network discovery is disabled for all network types by default. Once again, in an enterprise, almost all configuration is done using group policy. To find the policy that will allow us to configure network discovery, we're going to go into the computer policies, administrative templates, and then network. Now, if you look through the network policies here, you don't see network discovery. I don't know why they've done this to us. I guess just to make it a little more challenging, but there's a policy for link layer topology discovery. That's a fancy way of saying network discovery. That's technically the accurate name. I guess they decided to call it network discovery to make things a little easier on users so they didn't have to figure out what link layer topology meant. Anyway, basically this is network discovery, and by default it's turned off in a domain, so you generally don't have to worry about it. But you'll see there are a couple of policies here, and as I take a look at them, I'll see that they've been turned on. So in our scenario, they've asked us to turn off network discovery. This means I'm going to need to go in and disable this policy instead of leaving it enabled. So somebody has overridden the default, another IT guy, and I've been tasked with turning it off. So these are the two policies that I need, and disabling network discovery in the domain, once again, is as simple as disabling those policies. Now let's talk about managing wireless security. Now, in other lessons, I showed you how to connect to networks from an individual computer, but that doesn't necessarily help you in an organization. As we covered, you can connect to a wireless network and then type the security key. Now imagine that you're in an organization with 10,000 people and 10,000 mobile computers, and they all need to connect to your wireless network. You're going to go around and tell everybody, hey, the wireless network password is 123567. You could do that, but once John got fired and he walked away with that network password, you then have to go to the remaining 9,999 employees and tell them, hey, we don't trust that John guy, so we're going to have to change the password. Now it's something different. It would never work. There's just too much turnover. The security wouldn't work. Somebody would guess the password. It'd get leaked on the internet, and anybody would be able to connect to your wireless network. So in enterprises, there's a better way. There's a manageable way. Centralized authentication for wireless networks. Rather than typing a password in like you do in your home network, the wireless routers know just to contact a domain controller in your organization and say, hey, this user wants to connect to the wireless network. Is that okay? Ultimately, it allows your domain controllers to determine who can connect to the wireless network or not. So let's take a look at how to configure that. Once again, this is Windows Server 2012, and we're configuring group policy that will apply to our Windows 8 computers. The group policy settings are located under Windows Settings and then Wireless Network Policy under Security Settings. Now, by default, there are no wireless policies configured. So if you wanted your clients to be able to automatically connect to a network, you always have to create a new policy. Notice as I'm creating a policy, I get two different options here. One for Windows Vista, and later we're releases, and then one for Windows XP. XP was basically the first Windows operating system with some built-in wireless networking support, and it was pretty primitive, so they made one type of policy for XP computers, and then they had to revamp it when Vista came out. Hopefully you aren't running Windows XP anymore, so we'll just create a new policy. So here's what you need to do. You need to create profiles for the different types of networks that you have. And as I'm adding a profile here, you'll see I have a couple of options. I have an infrastructure and an ad hoc option. Almost every wireless network nowadays is an infrastructure network. That means you have a wireless access point, which is often called a wireless router. An ad hoc network is a wireless network between two client computers, basically. Whether it's a mobile phone or a PC, all these computers can kind of start up their own wireless network hotspot. When it's not a router and when it's not managed, it's called ad hoc. But organizations don't often use ad hoc networks, so we'll create an infrastructure network. And we'll create a profile for our fictional organization, Contoso. Now, within this profile, we're going to specify the SIDs. That's the security ID of the network. This is the name of the network that you connect to. It's what you see when you browse the networks. Organizations often have multiple SIDs, even though you can create multiple hotspots with the same SID. So we'll create a SID of Contoso, and then we'll do Contoso East and Contoso West. There are a couple of options down here. Select this if you want users to automatically connect to the network. And if there's a more preferred network, you can select that. Just basically makes it the most preferred network, and you probably always want your client computers connecting to your own internal network, so it's good to leave that one selected. Finally, this last checkbox, connect even if the network is not broadcasting. That sounds a little confusing because if it wasn't broadcasting, you wouldn't be able to see it, right? What they really mean is connect even if the network is not broadcasting the network name. So back 15 years ago when wireless networks were brand new, security experts, and I'm doing a little finger quote things with my hands, security experts thought it would make your network more secure if you didn't broadcast the SID, because then when people browsed wireless networks, they wouldn't see it as an option. Nowadays, we know that not broadcasting the SID doesn't make it any more secure. However, you'll still see some networks out there that don't broadcast the SID. If you happen to work in an organization that has one of these quiet networks, you'll have to select this checkbox if you want people to connect to it. Now, the Security tab allows you to configure the authentication used for that particular network. You'll just have to ask your network security guys. Nowadays, whenever possible, people use WPA2 Enterprise. It's the most secure, and it's actually about the only secure protocol currently available, but to my knowledge, WPA2 Enterprise hasn't been hacked especially well. Now, WPA2 Personal, and especially WPA Personal, is exceptionally unsecure and can be hacked in minutes by just about anybody with really cheap and free tools. The same applies for shared option here, which is WEP. Wired equivalent privacy can be hacked in minutes or seconds by just about anybody, especially the 64-bit variety. Anyway, nowadays most organizations use WPA2. For the scope of this exam, you don't have to know how to pick the different protocols. You'll just know that your network guy is going to tell you, and they'll tell you whether they use AES or TKIP encryption. Usually it's AES. Now we have to select the network authentication method. And you can see that you have the option to authenticate with a smart card, but I'll say most organizations use protected EAP, which is the default, and the authentication mode. As I mentioned earlier, in a domain, every user and every computer gets its own certificate. So either the user or the computer could authenticate, whichever one you grant the privileges to. The default is to allow either one of them. And on the Network Permissions tab here, we can see a few other useful options. You can select this checkbox to prevent connections to ad hoc networks. I would only do that if your security guys decide that it's a problem, because there are some legitimate uses for ad hoc networks, like sharing files in a meeting between client computers. If you've decided to block one of these networks, you can clear this checkbox to prevent users from even seeing networks that you don't want them to access. So maybe you have a network that is used just by the IT guys, and you don't want people to see it and think, why can't I get to that network? You could set up a profile for it and then block it and then clear that checkbox to prevent them from even seeing it. The allow everyone to create all user profiles checkbox is selected by default, and this allows a user to connect to a wireless network, and then a different user on the same computer can automatically connect to that same network. So basically, when you connect to a network, if this is selected, the network is bound to the entire computer. The only use group policy profiles for allowed networks checkbox prevents users from adding their own wireless profiles. This allows people to connect to only those profiles that you specify in group policy. So that takes away a lot of flexibility. Somebody couldn't just run to a coffee shop and connect to Wi-Fi there. But it gives you complete control over which networks they connect to, which can really reduce the security risks associated with mobile clients, because if a mobile client connects to an untrusted network, well, that network can intercept everything that's not encrypted, and that's a huge security risk. Under Windows 7 and later policy settings, we have some important checkboxes that you can select to also improve your security. Don't allow hosted networks. A hosted network basically runs a wireless access point in software on a Windows 7 or Windows 8 computer, and this allows other computers to connect to that hosted wireless network and share the computer's other network connection. So imagine you're in a hotel room and you plug your Windows 7 or Windows 8 computer into the hotel's Ethernet jack. That gives that one computer access to the internet. You could set up a hosted network to connect through it using your iPhone or your tablet or whatever other devices you have. I know me personally, when I'm in a hotel, I tend to have like 4 or 5 different devices I want to connect to the wireless network. So it basically allows you to share networks. It also introduces a security risk for enterprises, because somebody could be connected to their internal network with privileges and set up a hosted network that other strangers could then access. They might not set up a secure enough hosted network to meet the corporate security requirements, in other words. So select that checkbox if you don't want people to do that. The next checkbox, don't allow shared user credentials for network authentication. This basically prevents Windows from connecting to a wireless network before somebody logs on. So by default, if you need to, say, connect to a domain controller before you log on, of course, Windows has to connect to the wireless network first. This means that it's establishing a wireless network connection without actually having any user authenticated yet. If you don't want that to happen, if you want to force users to log on first before connecting to the wireless network, select that checkbox. You can still log on to the domain. Users will just have to log on with cached credentials before connecting to the wireless network and then in turn to the domain controller. The enable block period checkbox prevents users from trying to connect to a wireless network multiple times in a row. So if they are trying to connect to a WPA network, WPA personal network that requires a password type, and they mistype the password, and you have that enable block period selected, they'd have to wait 20 minutes or however long you specify before retyping the password. This, I suppose, could reduce the risk of a brute force attack using one of your domain-controlled computers, but not really, because a hacker would be using a phone or another device or a computer that you didn't control to hack into your network. So I really don't see the benefit of that, but that's how it works. And finally, that last checkbox, don't allow Wi-Fi direct groups. Wi-Fi direct is this fairly new technology that's kind of replacing ad hoc wireless networks. And it allows two computers to connect directly to share files or pictures or stream media, tasks that you might have otherwise done with Bluetooth. Groups, of course, allow 3 or 4 or more computers to do this kind of sharing. So basically setting up ad hoc wireless network to do any sort of sharing. If you don't like that, you can select that checkbox and it'll be disabled in your client computers. And that's basically all you need to do for the client configuration. There's a lot of configuration that the network guys need to do to configure the wireless access points to talk to the Radius servers. Radius is the protocol that translates between the language the wireless access points speak and the domain controllers. But from the client perspective, you really just need to create a wireless network policy. I also want to show you this, the wired network policies. Now, we put a lot of energy into wireless networks. Why? Because anybody could sit in the parking lot and connect to your wireless network. Wired networks feel a little more secure because there's some physical security there. To connect to a wired network, you need to run an Ethernet cable from your computer to the wired network. And we probably don't let anybody in the office plug their computer in, right? Well, some organizations kind of do. Like, they'll have a waiting room and sometimes there'll be a network port right in the wall. And somebody could come in and request a meeting and connect their computer there and get access to everything on the network. You might also have a contractor come in, or a cleaning person, or there's any number of people who have physical access to your facility who you don't want to have access to your network, right? So there's a protocol for wired network policies that provides similar security to wireless network policies, and every organization should use it. The certification exam doesn't specifically mention wired network policies. I just want you to know about it. If you're setting up a new network, you should configure wired network policies to provide similar levels of authentication to wireless networks. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.